Hi, I'm Scotty. Welcome to my channel, Scotty's Clock World. Thanks for dropping by. Now, that and that and that and that are new bushings, so I assume that they're going to be alright. But we'll look at the first wheel first, that one there. Well, yep, he needs to be changed. That's a new one. Second wheel, no, looks pretty good. Third wheel, not sloppy on the other side, on the front, but on the back, but not on the front. And the escape wheel. Oh, dear oh dear, look at that. That one will have to be done. That's atrocious. Alright, fair enough. Let's look at the back plate now. And we'll look at that pivot there. And it's not too bad. Second wheel. Yeah, great. That'll have to be redone. Third wheel. That pivot there. Don't even bother. I'll take a close-up of that. That's pretty impressive, the amount of slop in that. Alright, well, if we've got to do more than 3/4, we'll do the whole lot at the same time. This idea of just doing the really bad ones and then leaving the medium bad ones for someone else to do doesn't cut it. It's very poor workmanship. If you're replacing one side, you replace the other one. We're ready to start doing the bushing on the plates now. And the first one I'll start with, if I can get a grip on this and not lose it, is I'll start off on the third wheel. I've got some drawings I'm going to do on the whiteboard to explain how we set up and find the correct centre of a hole that's so dramatically bad as that. And then we'll actually get on to the rebushing. Looking at the bushing we've got there we saw a moment ago, that's the bushing and it's inside the plate, and we notice that the hole in the bushing has been worn oblong like so. Now the problem is, if you just put a reamer straight down into there, we'll use this to demonstrate a reamer. If you put the reamer straight down into there, it will automatically find halfway between the two extremities. And when you're turning it, it will drop down and it will make a hole that big. Round, but that big, and it'll be in the centre of the bushing. Take the middle bit out, do it like that, that'll be easy to see. And that'll be the size of your bushing hole, which is way, way too big. So there's a method we use to stop that happening. We'll go back to our bushing again, which sort of looks a bit round. And our hole, exaggerated, looks like that. The first thing we do is work out where the centre of the hole should be. The centre of the hole is equidistant all the way round there in each direction. Now you can see, even on my diagram here, that the bottom part of the hole here is way out of line compared to the top half up there. So what we have to do, having seen from our last drawing that the reamer will automatically find the middle between that point and that point, that's the last thing that we want to happen. So what we do is we open up this side of the bushing to the same distance as is on the bottom down there. It's relatively the same. And how we do that is we use a rat tail file, one of those. Don't use a square file or a triangular file, they'll make it even worse. So what we do is we gradually file away on the top up here like so, until the distance from the outside of the new hole to the centre is very close from the centre to the bottom down here. And then having done that, when the reamer goes into the centre, it will then open up that distance between there and there, and the centre of the hole will be there. I'll remove this top piece. I'll get rid of that and redo that. So that was our original hole. If we just dropped the reamer in now, the halfway point between the top and the bottom of that hole is about there. And you can see that that's way below the actual centre of the bushing where the pivot should go. And we want the pivot to go right in the centre. So if we start reaming out the hole here, that will then be the centre of the hole when it's finished, and then you drop a new bushing in it instead of, that's your plate coming down there, your bushing, the plate coming down there, instead of the pivot sitting exactly parallel on both sides of the bushing and running smoothly around. And then once it gets a drop of oil on it, the friction is really reduced right down. Instead of that happening, on our second scenario here, there's our plate. Once again, we've put the bushing in, but it's out of alignment. So what happens then, exaggerated, is that the pivot then sits like that in the bushing. And that's how you get score marks on the top and down that end of a pivot as it spins round. Even though it's been oiled, there's very little friction. Well, there's zero friction up here. All the friction is on that point there and on that point there. So you then end up with a pivot that has got a line running around there and a very faint one running around there, but a heavy line in around there. Then that has to be removed before you can use the pivot again. And the only way to really remove that is to use a lathe. You can't do it by popsicle sticks, etc., and just sort of filing it in your hand like that. It's not going to be round. Right, so that's what we're going to do. Initially, I'll reset the hole on that bushing using a rat tail file. Then I'll replace the bushing. Because there's so many to do, it's going to take quite some period of time to do. I'll use my bushing machine. It is a very, very efficient machine, and I am quite fast on it because I've done a hell of a lot of bushings on it. So it'll be a lot faster than just using a reamer in a pin vise. But you'll see the operation as how I do it, and I'll do one, this really bad one, and the pivot will sit there and it won't be sliding up and down in that direction. So that's what we're going to do now. Right, this is the bushing that we're going to replace initially, this really, really bad one on the third wheel. So I'll take it out of the plate. I'll do one side of this initially, then I'll do the rest of them offline. So that is the plate, and that's the positioning of the wheel on it. So the first thing we'll have to do is we'll have to measure the diameter on a vernier, zero it off first, and then measure the diameter of the pivot. which we measure there. 1.09 mils. Right, put the vernier aside. I'll put the wheel face down with the pivot we're working on into a foam block so we know which is which end we're working on. I'll write that down on my notepad. .09 millimeters. Next thing we do is we have a look at our Bergeon, our box of Bergeon bushes, and that rubber band looks pretty much expired, I think. It's all fallen to pieces. Alright, so we're looking for 1.09 millimeters. A number 42, I'll take a photo and you'll be able to see this more accurately in a moment. Number 42 is 1 mil, and a number 43 is 1.10 mil. So initially, just to check, I'll get out a number 43, which is one of those bushings there. Put it on my hand. Glove's a bit tight, it's going to move around, but put it on my hand like so. Then get the pivot and see if we can insert it into the bushing. And we can't quite. Not quite. Alright. So that appears to be, though that's 1.10, now there's 1.09, a fraction of a difference there. But obviously a number 42 is not going to fit. Alright, so we'll write that down. It's a number 43 bushing. Number 43 bushing, it's 1.09 millimeters, and the external diameter of the bushing is 3.00 millimeters. So that's the size of the largest reamer that we're going to use. Okay, we'll align it on here and then drop the center finding tool into it, and that will now, I'll bring these supports up, tie them down to keep them in place,